Hello and welcome back to another episode of Math with Sohn. I'm looking forward to a great lesson, so let's get into it. Today, we're going to be focusing on intersecting chords and secants, and we're going to be comparing when we have angle problems compared to when we're looking for the chord and secant length. Okay, so it's still circles. We're going to have, instead of an X in the middle of the problem, you're going to have, let's say, what I call an ice cream cone type of problem, where we have the angle far outside of the circle. Okay? So for these, the first one we're going to be dealing with is just going to be finding this angle out right here. I'm going to call that X. And we have normally the length from here to here provided to you. We'll call that an A and a B. Let's say this is 100. And you would hope that you would also be provided this short arc from here to here. And let's just call that 40. It's going to have to be smaller than the 100. And if you're asked to find the angle, or if you're asked to find either this bigger arc or this smaller arc, what you will have to do is you have to take the big arc and subtract the small arc, and that would equal 2 times the angle. And in this case, that would be 100 degrees for the big arc minus 40 degrees for the small arc would have to equal 2 times the angle. In this case, the angle is X. So you do 100 minus 40, which is 60, and that would equal 2x. And then when you divide by 2, you get your answer, which is x is equal to 30. Okay? So that's the problems that you'll have if you have to find the angle or this either the big arc length measurement, not length, and or the small measurement of that arc there. Sometimes you have to, subtract some things from 360 to find the big arc or the small arc measurement, but normally you won't have to. All right? The other type of problem will not be dealing with finding the measurements of those arcs. The other type of problem will be dealing with finding the lengths of the secants that are created. So we got secant number 1, secant number 2, intersecting right there. And in this case, the X is going to most likely be either on the inside of this chord, but if you lengthen it, it's a secant. So we'll call that AB. And then you'll also have a length from A to C, which could be 4. And that would be the length of that line. We'll call this part 5. And we'll call that a R and an S. And we'll call this part from here to here a, I'm going to go with 6. Okay? So for these problems, they're going to be dealing with a completely different formula. And I call it the outside times both will have to equal the outside times both. And the outside in this case is referring to the 4 and the 5. So you can pick either the 4 or the 5 for either side of the equation. I'm just going to start with the 4. No, I'm going to start with the 5. We're going to start with the 5. We got outside, which is 5. And both refers to the outside and this inside put together. So that means that we're going to have to do a 5 plus 6. Normally you can do that in your head and just write 11. And that would be both from C all the way to S, the outside, the 5, and the inside, the 6. You put them both together. In this case, we have the other part, this bottom line from C to B. We have the outside as 4 times both of them. Well, both of them in this case is not going to just be a 4 or an x, but we have to add them together, so that would be 4 plus x. And we just have to follow through with that equation. So on the left side of the equation, we have 5 really times 11. And on the right side of the equation, we have to distribute the 4, giving us 16 plus 4x. We got 5 times 11, which makes 55, equals 16 plus 4x. Continue to solve the equation. Subtract 16, subtract 16. We will get 55 minus 16, which is going to be a 9, 39. Yep, 39 is equal to 4x. And then you just divide by 4. So you can either keep the answer as 39 divided by 4, or you can write it as the decimal, which in this case is going to be 9.75 is equal to x. And that would be our answer there. Okay, so we're going to do a few more examples of these, and they're just going to be the slightly harder versions of that, as normal, because they always make it a little bit more difficult. Just changing the problem slightly can make the problem that much more difficult. A little bit harder. We're going to take our circle. We're going to make it an ice cream cone type of problem. But instead of giving us all of the angle measurements, or arc measurements, I am going to maybe make it a little more difficult. We'll see here. Let's call that A, B, C, and D. I'm going to say that this is x minus 3 for A to B. And I am going, not A to B, A to D. Oof, what am I thinking? For B to C, I'm going to say that's 2x plus 4. And I'm actually going to be giving us the angle in this case. I'm going to say the angle is 40 degrees. So we're given our big arc, we're given our small arc, and we're given the angle, but we need to find x still. So it's going to be the big arc minus the small arc equals 2 times the angle, which in this case, the big arc is 2x plus 4. The small arc is the quantity x minus 3. And the angle, of course, is right there. That's 40 degrees. So 2 times 40 would go right there. We are going to have to distribute the negative to make this 2x plus 4 minus x plus 3, because you're distributing a negative, you're going to change the signs of these, making the negatives positive and the positives negative, and that would equal 80. 2 times 40 makes 80. Combine like terms on the left side of the equation. We got 2x minus an x, that makes 1x. You don't even have to write the 1. We got a 4 and a 3. You add those together, you get 7. And that would equal 80. Subtract 7. 1x equals 73, which really just means x is equal to 73. So you can box that and call it a day. And I used the 1 to make the box, so it was convenient. All right, so that's a little bit of a harder version of the big arc minus a small arc equals 2 times the angle. All right, so for our last ice cream cone problem, we are going to make it just ever so slightly more difficult. Not going to change much, but for the part on the outside from A to B, I'm going to put 3. And from B to C, I'm going to say x plus 10. And on the outside here, I'm going to say 5 and an x plus 1 there. So for this problem, we still have to do the outside plus both equals the outside plus both. So we have outside times both equals the outside times both. I think I said plus the first time. It's times both. So we have 3 on the outside times both of them. In the case this time, both of them is going to be a 3 and an x plus 10. And the outside here we have 5 times both of them, which would be a 5 and an x plus 1. So we have to combine like terms here. We could distribute in the beginning. I don't like to. So I'm going to say 3 and 10 combine to make 13. And this 5 and that 1 combine to make 6. And now it turns into a more like regular distribution. So we take the 3 and multiply by both terms. You end up with 3x plus 39. You take the 5 and multiply, we get 5x plus 30. I am going to move the 3x over by subtracting. We get 39 is equal to 2x plus 30. We have to subtract the 30. And when we subtract 30, you end up with 9 is equal to 2x. And when you divide 9 by 2, you get 4.5. And you might be asked to find something slightly different this time. What if we were wanting to find B to C? Well, B to C is from here to here, not the arc. It would have to have an arc symbol over it. I have a line symbol representing that we want to find the chord B to C. So if we did that, we'd have to plug in 4.5 for that x. So if we did 4.5 plus 10, you'd find out the length of B to C is just 14.5. And we could get that answer as well. All right, so that's going to do it for this episode. Until tomorrow, stay thirsty for knowledge, and see everybody later. Bye.